So this is 20.1.1 Arithmetic Sequences Part 2. And what we're going to be doing in this lesson is continuing to work with arithmetic sequences, but we will have a formula that can be used to help us. And we have to get really used to using this formula. So this is the warm-up I was alluding to a few minutes ago. If you just take a second and look at those numbers, that sequence, 10, comma, so this is in the unit handout on page 3, I'm guessing. Okay. 10, comma, 16, comma, 22, comma, 28. The first question, A, says, what do you add to the first term to get the second term? So I want you to write in a number that you add to the first term in this case to get the second term. So the question is, what do you add to 10 to get 16? The answer is 6. Okay. And let's walk away from A for a second. I know there's another blank there, but let's do the same thing for B. What is it you would add to the first term to get the third term? So I'm asking you to compare the two numbers, 10 and 22. And the answer is you add 12 to the first term to get the third term. And if I say, what do you add to the first term to get the fourth term? You can look at the first term of 10 and the fourth term of 28 and say, well, that's 18. However, we want to make this more general. We want to learn something from this that's true about any arithmetic sequence. In this one, the first blank is 6, the second blank is 12, the third blank is 18. But in every arithmetic sequence, the answer to this question, A, would be you're adding one common difference to the first term to get the second term. The answer to B for any arithmetic sequence is the thing that you add to the first term to get the third term is two common differences. You go plus D, whatever D is. Here D happens to be 6, but it doesn't always happen to be 6 clearly. And I hope it's not lost on you that 18 is 3 common differences. And we're building patterns here, everybody. And the pattern has to do with which term number we're finding and how it compares to how many common differences we're adding. So when we're finding the second term, you're adding one common difference. When you're finding the third, you're adding 2. When you're finding the fourth, you're adding 3. Which means you're always adding one fewer common differences than the term number that you're after to the first term. So this would be 4 common differences. We don't even need to find the fifth term to answer this question. I mean, I suppose we could. We would add 6 again, and I guess you get 34. And the common difference is 6, and 4 times 6 is 24. And it all checks out. 24 plus 10 would take you to 34. I don't think we need to worry about the first blank here. Like, for example, what would we add to the first term to get the 23rd term? 22 common differences. And we can certainly figure out what that is, but we're not going to do it, everybody, by extending this sequence to the 23rd term. We know the common difference is 6, so this is going to be 22 times 6, which I want to say is 132. What we want to do is make this as general as possible now. Forget about this sequence. We're going to talk about any arithmetic sequence, and forget about the 23rd term or the 28th term. I'm just going to talk about the nth term. So what is it you add to the first term to get the nth term? N can be any number you want, but I don't want an answer that has a number in it. Who can tell me? I understand this throws you for a loop because you don't know what this really means. It means any term. If I want the fifth term, I add 4 common differences. If I want the nth term, then I want to add this many common differences. N minus 1. So listen, if I wanted to find the 25th term, I could put the number 25 in for n, and this would become 24 common differences, right? So it devolves into whatever I need it for. I just have to put in the value for n. All right. So use the answer from F to develop a formula for the general term of any arithmetic sequence. So this is the idea now. This is the nth term. This could be any term you want. If n were 5, then it's the 5th term. This is going to become t sub 5. If n was 1,000,000, this would be t sub 1,000,000. I would be finding the 1,000,000th term. If it were the 5th term, then I would take the first term and I would add 4 common differences, right? If it were the 1,000,000th term, I would take the first term and add 999,999 common differences. But I want it for any term. This is called the general term or the nth term. So I'm going to add n minus 1 common differences. And this formula, and we'll talk a lot about this formula today and use it a lot, takes all of the puzzle aspects out of these problems. Okay? So we take a look on, I believe, the next page, or middle of this page, I guess we're still on. There's the formula. I would like to highlight a couple of things for you. This, of course, is the first term, and this is the common difference. And the thing I want to highlight, which will become useful throughout the rest of the course and next year as well in 30-1, is that these are both called parameters. T1 and D are parameters. Parameters are numbers that define a relationship. And you may think, oh, what's the big deal? It's just a word. It does become important. In fact, we used the concept of a parameter this morning in my Math 30-1 class. T sub n and n are not parameters, they are variables. There's a difference. Variables are things that change in a relationship. What I am saying is, and we can take a particular sequence to demonstrate this. Let's take this sequence. I'll go one more. Right? That is a sequence. Now, it turns out that the first term is equal to 3, and the common difference is equal to 2. And I hope you would agree on that. Yes? Okay. Whether we're talking about this term 9, or the second term 5, or the 100th term, whatever it is, what's written in red is true for every term in this sequence. The first term in the sequence is 3, and the common difference is 2. It doesn't matter which term we're talking about. These numbers define the sequence. However, these things are variables. They change. The value of Tn depends on what n we're talking about. The value of n depends on what Tn we're talking about. They change. They're variables. These, however, are parameters. We have sequence 1 of, say, 3, 5, 7, 9. We have sequence 2 of, it doesn't matter, negative 10, 0, 10, 20. I hope everybody would agree that these are both arithmetic. And I hope you can look at them quite simply and tell me what the common difference of each one is and what the first term is. Now, I've just told you, and it's in your notes, that we have this new formula that relates well, I didn't say it this way, but I'm going to now, that relates these variables. That if you know which term you're after, say n equals 10, you can use the formula to find the 10th term. Here, Tn will be equal to 3 plus n minus 1 times 2. Come on. Why? Because T1, the parameter T1 for this sequence is 3, and the parameter D is 2. Here's my equation that I can use to unlock any piece of this sequence. It has variables, n and Tn, and the parameters that make my work possible. Here, that would be what it would be. Are you with me here on the general idea that a parameter is just a number that kind of defines what's going on, whereas the variables are the pieces in the whole pattern? Okay. All right. Examples. Write the general term for each of the following arithmetic sequences and find the 40th term. So here's the end goal, everybody. We're going to be able to find the 40th term without saying how many common differences do I add. We go to the formula, which will be given to you for exams. We make a list of our parameters, T1 and D, and this is how I would describe what's going on from here on in. If you know those, you unlock anything related to this sequence. If you know those two things, you can tell me anything about the sequence. So T1 is -6, and D is 4. Everybody just give that a little bit of thought and make sure you understand where I'm getting those numbers from. Okay. So I load them in, and I get the nth term, which I know this is still new to you, but another way of saying the nth term is to say any term will be the first term plus n minus 1 times 4. I would really prefer if you got in the habit of putting a set of brackets around that D, whatever it is. So now, everybody, if I want to find the 40th term, I just have to put 40 here. However, we want to simplify that first. This is a mess. So we want to simplify it. We're going to do all the multiplication before the addition and subtraction, which means I have to take n minus 1 times 4. What does that mean? It means I need to take the 4 and multiply by the -1, and the 4 and multiply by the n. And I get -6 plus 4n minus 4. So I get T sub n equals 4n minus 10. -6 and -4 are similar terms. You can combine them together and say -10. I would ask you to check something out here. You don't need to write this down. Go ahead and put 1 in here for n and see what this turns into. So if I put 1 in for n, I put a 1 here, I put a 1 here, and what do I get? I get T sub 1 equals -6. Yep. What if I did that with 2? I mean, for goodness sake, we're not going to do this all the time. I'm demonstrating to you that the result is correct. If I do that for 2, then here and here I put a 2 because n is 2. So what do I get? I get T sub 2 equals 4 times 2 minus 10. 4 times 2 is 8. 8 minus 10 is -2. Yeah, the second term is -2. You can try it with 3, etc. So this, everybody, is the general term. T sub n in this sequence is 4n minus 10. All right? So what is the 40th term? Well, we simply put in 40 for n. 4 times 40 minus 10, can you confirm it's 160? 150. Right. 4 times 40 is 160, minus the 10 is 150. So the 40th term is 150. Let's try another one. 1.75, 1.5, 1.25. So the first term, that parameter is 1.75. The common difference is negative 0.25. You might want to, if you have a calculator handy, check that or check that in your head. Just make sure my reasoning is right, that I'm adding negative 0.25 each time to get to the next term. Here's my general term formula. So I put in the parameters. I never put numbers in for the variables when I'm finding the equation. So if it says find the 40th term, I'm not going to put 40 in for n now. I want to get the equation first. So it'll be 1.75 plus n minus 1 times negative 0.25. And we're going to expand this out and simplify it. T sub n is 1.75. Now I need to multiply this negative 0.25 by the negative 1 and the negative 0.25 by the n. So I'm going to get negative 0.25n and positive 0.25. And like the last question, I have a couple of numbers that are, well, they're numbers, I can add them together. This is what I get. 1.75 plus 0.25 is 2. Now, before we find the 40th term, I mentioned yesterday that there's a way to use your graphing calculator to generate the sequence. You need to know this. You need to know the formula for T sub n. So if you follow along on your calculator, you will find this helpful at some point, I'm sure. It is something you need to know how to do. So we're going to go into y equals and clear out anything that you have there. And you're going to enter this for y. So we're thinking of this as y. Say y1. And we're thinking of this as x. So I'm going to enter 2 minus 0.25x. Now I'm not going to graph it because it's going to be a line. And by the way, this sequence is not a line, it's just going to be a bunch of dots if we actually graphed it. So we don't want to look at the graph. What we want to do is go to table set. So instead of going to window, go second window and you'll be in table set. And we want to have a table start. This will make sense to you in a minute. We want to have a table start of 1, and this refers to values of x. So I'm going to tell the calculator to generate a table using the first value of x being 1, and this delta table, that's supposed to be a triangle, which means delta, is also going to be 1. And what I'm telling the calculator is you choose x equals 1, and then the next x go 1 more, and then 1 more, and then 1 more. So I'm saying we're going to go with n equals 1, 2, 3, etc. And then you go automatic. How many of you have ever poked around with the tables before in other math classes? Unlikely. So now, instead of going to graph, we go to the table. And there's our sequence. this table, whoops, what did I do? Must have deleted the page. Yeah. This table is that. Which means, you know what, everybody, if we want to find the 40th term and we just don't feel like doing much work, we can scroll down and get the 40th term. Or go back to your table setup and start at 40. Right? And now if I go to my table, the 40th term is negative 8. But algebraically, let's find the 40th term. T sub 40 equals 2 minus 0.25 times 40. Do me a favor and run that through your calculator and make sure that you get negative 8.
Sorry, how do you get to the table?
Second graph.
Mine just throws error.
Okay, so there are a number of problems you could have because you have errors. One of them is, I want you to check this first. Go to y equals. Does this happen to be highlighted at the top? Does plot 1 happen to be dark? No, and plot 2 isn't. Okay. The other thing is, scroll down and see if you have anything else entered under y. Okay, you have something entered under y10 or y whatever that you're there's syntax that's wrong with it. So if I just entered a bunch of gibberish, my calculator is going to try to deliver a table based on that gibberish, and that should fix it. All right, let's move on. Algebraically determine which term in the sequence has a value of 220. I'm not expecting that you remember everything that we talk about, but how many of you see that this question is the same type of question as the one where we were trying to find out which term was 170? It's the exact same thing. Well, what we can do is find the general term formula first. In question 1, we were putting n equals 40 in and figuring out what Tn is. We're going to do the opposite now. And I want to make a note here that in this question, that was the question, wasn't it? Okay. All right. In this question, that's what it's asking. It's asking where are we going to find 220 for a term value? Okay, let's keep that in mind. The first term is 10. The common difference is 3. This gets a bit repetitive, but that's okay. You learn from repetitiveness sometimes. T sub n, according to the formula, is T sub 1 plus n minus 1 common differences, which is 3. And I would always like you, please, you don't have to, but in order to reach all of you as well as I can, I want everybody to, always simplify this before you use it. You could put in 220 right now and find n. You could, but I don't want you to get into that habit. That's a bad habit. Let's simplify this. T sub n is 10 plus 3n minus 3, because I have to multiply that 3 by the n minus 1, which means T sub n is 7 plus 3n. 10 minus 3 is 7, right? Well, there's the key. There's the key to the problem. What we're going to do is the following, everybody. We are going to take this. What's going on here? We are going to take this number and load it in here. This number is the answer to the question. Right? Instead of putting in 40 and finding out what the 40th term is, we're putting in for Tn a term and finding out what term number it is. We're just working backwards. It's not a difficult algebraic problem. We get 220 equals 7 plus 3n, a two-step linear equation to solve, a grade 7 equation. Subtract 3 from both sides, subtract 7 from both sides, and divide both sides by 3. And I think, but I want you to do the work, I think you get 71. Okay. So you'll notice that at this point in the game, I'm not about to explain how we solve that on paper. Subtract 7 from both sides, you get 213. Divide it by 3, you get 71. That means that the number that goes in for n to give us 220 coming out is 71, so it's the 71st term. You could have solved that 170 question the same way. So take a look at this one. How many terms are in this sequence? It's the exact same question. Different numbers. It's the same question. Because, everybody, do you agree that there is a term with a value of negative 139? Do you agree it's the last term in the sequence? So whatever term number it is how many terms there are. The logic's a little sneaky, but if we find out that that's the 13th term, and it's the last term, then there must be only 13 terms. So what do we do first? We determine the general term. T sub n is the first term plus n minus 1 times the common difference. I'll give everybody a minute to percolate mentally on that. We're always saying, because it's the formula, T sub n is the first term plus n minus 1 times the common difference. Are we okay with that? Any questions there? Okay. Let's expand it out. I would imagine there are a few people in the room who are capable of expanding this out in one step, meaning you multiply the negative 4 and the negative 1 together and add the 5. I would just caution you that the fewer steps you make, the more mistakes you make usually over time. Look at 5 minus 4n plus 4. So I get T sub n equals 9 minus 4n. So we're going to put 139 in for Tn, negative 139. This does require a bit of help from me, I think. A bit of guidance, a bit of advice. The term that we're trying to find, I mean, not term like in a sequence, but the thing we're trying to find here is negative. The n is the unknown and it has a negative with it. If we leave that term there, we're going to have to divide by negatives and that's awkward. I would always recommend that take the term that's negative that you want to find a piece of and move it to the other side where it becomes positive. And then I added 139 to both sides. So I get 4n equals 148. Can you do that division for me and let me know if you get 37? Quickly here, Is there one more question after the next one? Okay. We're not going to do the final example. Well, I'll deal with the final example tomorrow. We have one more example to go, and then we'll skip the final one. But if you just look up here, I could go 9 minus 4n. Well, it's 4x. That's what Tn is. I could start at 1 and go up by 1, and then I could go table hopping to find negative 139, right? I could scroll down, and on your calculator, you would be able to hold the key down. I can't here because then it'll think I'm right-clicking. You can see that I'm quite a ways away, so maybe you'll say, you know what, I'm going to start at 30. I'm going to start at 30 and see if that gets me closer. And anyway, you could get there that way too. Okay. So one more example I want to do with you today. We have an arithmetic sequence, and somebody's already done the work and they've given you the general term. This is not an onerous example. It's not a lot of work or difficult or time consuming, but there's something important that's about it that I want you to consider. Sketch a graph showing the relationship between t sub n and n. So we can make a table of values. Well, before I do, would you agree that this is a linear equation? That the graph should have a y-intercept of 4. Now, don't draw anything yet. I'm about to draw something that I'm going to then erase. That if this were a Math 10 class, you'd say, well, the y-intercept is 4. And the slope is 2. That means I go over 1 and up 2. Over 1 and up 2. Over 1 and up 2. So I can draw a line here. Okay. What do we have? I guess I got off track. Is that better? That's good enough. Can somebody tell me what's brutally wrong with this as a graph for this sequence? Does this line pass through 0, 4? Yes. Is there a 0th term? No. Does this graph pass through a point where x is 0.75? Yes. But there's no 0.75th term. So when we plot these points, that's all the graph is going to be, is just points. We can't draw a line. So let's get to it. Reset this. Let's make a tiny table of values. Let's just go up to the 3rd term. So you're going to calculate for me what the 1st term, 2nd term, and 3rd term are. And I don't know that you need to write anything down for that, or probably not even use your calculator. You can use your calculator if you want. You're putting in 1 for n to get the 1st term, 2 for n to get the 2nd, etc. Am I wrong, or is the 1st term not 6? 6, isn't it? Put in 2 for n, 2 times 1, plus 4 is 6. 8. 10. Why is this going up by 2 each time we increase n by 1? Because the common difference happens to be 2. So we're just going to plot these points. 1, 4, 2, 6, 3, oh, pardon me, 1, 6, 2, 8. Get my eyes checked. 3, 10. It's going up by 2 each time. So that's what the graph looks like. That's it. Does anybody remember the difference between continuous and discrete? Continuous would be if we could draw a line through it and connect all the points because the stuff exists everywhere. So when I pour water into a cup and I talk about the volume of water, that volume of water is continuous. If I talk about taking a cup and I've got a whole bunch of poker chips that I'm going to pick up and put in the cup, and we're going to measure the number of poker chips in the cup, that's not continuous. It goes from 1 to 2 to 3, etc. There's no decimals. So this is discrete. And why is this graph linear? Because it's an arithmetic sequence. An arithmetic sequence will always be linear because of the common difference, which, by the way, is the slope of the line. But there's a common difference in this case of 2, and that means, I think I showed this to you visually yesterday, if you look at me right now, that if you started a term here and you go one more term over, you go up by 2 because the common difference is 2. And from there, you go one more term over and you go up by 2. So you're going over 1, up 2, over 1, up 2, over 1, up 2. You're going to get a straight line. And that's it. So this is since there is a common difference. And we'll do the final example tomorrow. But what that means is I want to be careful about what I assign you because since we're not doing that example today, there might be a question that you don't know how to do.